All right, ladies and gentlemen, this is 4.2, which is the mean value theorem and Rolle's theorem. This is actually quite short. I've only got a couple slides for it. So let's get busy. All right, so just in general, remember we had the intermediate value theorem, IVT. We talked about continuous functions and had a little thorough definition, but it dealt more with values, okay? Knowing that if you had an f of a value and an f of b value, there was some c between a and b that gave you that f of c value that was in between the f of a and the f of b, okay? Hopefully that wasn't too confusing, but it was for a continuous function. Mean value theorem doesn't deal with really your outputs for y and finding the respective x that's in between it. What it deals with slope. Okay, so here's what I'm going to do. I'm just going to draw a secant line here. All right, and I'm just going to mark this here as a point, and there somewhere as a point. Let's just call this A, and this is B, and then work with this definition. Okay, it says let f be a function that is continuous. Okay, here's my f. It is continuous on the closed interval from A to B. So even from A to B, A to B, it is continuous. And it's differentiable, okay? And you can see that it is continuous and there are no like sharp curves or sharp edges, so it is differentiable between A and B. And here's what it says. It says there must be a C within A and B. So there must be within here, okay, some C such that when you draw a point to the curve, okay, that the point of tangency, okay, which is really your f prime of C, okay, will have the same slope as the slope made by the endpoints of your function. Okay, so maybe my C is right about here, okay, and I can't draw a line as straight as the one I just did and have it be the same slope. But here's the idea is that my C is between my A and my B. And if I drew the point straight down, this particular C will give me a tangent line that is equal to the slope of what is made by my endpoints, okay? And that's the mean value theorem, that you have a matching derivative from your endpoints based off some C that's in between it, okay? And you can see that this is a kind of a visual perspective of this theorem, okay? So again, make sure that you say that it is continuous and differentiable. Okay, differentiable between your A and your B. Okay, so that's a visual perspective. Let's talk about a more symbolic representation. Okay, and here's what I got. Okay, I've got this function here. You know it's a parabola, which means you know it has to be continuous, and you know it's differentiable everywhere. So that's kind of good. And we want to find the value between 1 and 4. Okay, so this has to be between 1 and 4. Okay, such that the slope of the tangent line has to be equal to the slope that's provided by those two endpoints. Okay, so MVT, mean value theorem, you can abbreviate that. There are 3 steps. Very easy. First step, based off the formula that you had before, I'm just going to switch over this real quick. Actually, it's right up here. Sorry. I'm actually going to do the back piece. Okay, now they don't traditionally use capital letters, but that is the fonts that is used for this fancy PowerPoint. I didn't pick it, it's just there. And I can't change it actually. So based on how it's written on the previous part, those titles. So, but here's the idea. This is your B, this is your A at your coordinate. Okay, so f of B is 4. Sorry, f of B is plug in your 4. So when you plug in 4 here, 4 squared is 16, minus 4 times 4 is also 16, plus 3 is 3. And when you plug in 1, that's 1 minus 4 is negative 3, plus 3 is 0. Okay, all over 4 minus 1. Okay, and again, if you're confused with what I just did, this is f of 4 minus f of 1. All right, and that 3 over 3 gives me 1. Okay, so that's step 1. Step 2 is to take the derivative here, okay, which is what you see here. Okay, this this piece way up there. Take the derivative. So f prime of x is equal to 2x minus 4. Okay. And then step 3 is just to set these equal to each other. Okay. And you don't have to write 1 and 2 and 3. It's just, it's not elementary, but I'm just going to show process. Okay. So I'm going to add 4 to both sides. And I get x is equal to 5/2. Okay. Which means if you draw this parabola, okay, and look at these boundaries and draw a line, a secant line from 1 to 4, okay, x equals 1 and x equals 4, the slope of that secant line will be the same as the tangent line at x equals 5/2. Now, here's what we got to make sure. Is this value in between 1 and 4? And you find that, yeah, that's the same as 2.5, and 2.5 is between 1 and 4. Okay. Someone in an hour said, is it always exactly in between the two? And it's not. It just happened to be in this case. Okay, so 2.5 is your answer. Okay, so same question here. First of all, you'll notice that you have an x in your denominator. So what that means is it is not differentiable. This is f of x. Not differentiable at x equals, well, let's see. What makes this undefined? Well, at x equals 0. Now, you can stop your problem and say that it doesn't work if 0 is actually in between those. And unfortunately, 0 is not, so you must proceed. Okay. So we will first find the slope. This is f of 4 minus f of 1 all over 4 minus 1. So we won't always have 4s and 1s, but we do in these two. And so when you plug in 4 here, you get 2 minus 4 divided by 4 is 1. And your f of 1 is a negative 2. Okay, so when you plug in 1 here, it's 2 minus 4, which is negative 2. This is also 3 over 3. I don't mean to be anticlimactic, but your slope here is 1. And then what you're going to do is you'll set this equal to the derivative. So f prime of x is equal to the derivative of 2 is 0. Now, be careful of this. This is really negative 4x2. And if I move that into the denominator, like I showed here, to the negative 1 power. Okay, and so if you take the derivative, negative 1 times negative 4 is 4x to the negative 2. And that just turns out to be 4 over x squared. All right, so that's your derivative, kind of an ugly one. But we'll set these equal to each other now. Okay, you will cross multiply. Put a little 1 underneath there if you want to. And if you take the square root of each side, you get plus or minus 2. Now, here's the deal. I only care about between 1 and 4. Okay, and so you may have a slope of let's just leave those at 2 and negative 2. So what I'm going to do is I'm going to set x equals 2 and negative 2 to, actually that's my answer, sorry. Going back to what I said, sorry, I'm tired. You have x equals 2 and x equals negative 2. And I don't want both of those. I only want the one that is in between them. And sometimes both of them are, but not this one. Okay, so in the end, all I want is that x equals 2. Okay, and you are done. All right, so rolls through. I'm like, dang, I gotta do something all brand new. Okay, not really. So here, let's do step 1 way over here. That doesn't mean there's more work. F of 3 minus f of 1 all over 3 minus 1. Okay, and if you plug in 3 here, okay, 3 squared is 9. Okay, minus 4 times 3 is 12. Okay, plus 4. So 9 minus 12 is negative 3 plus 4 is, sorry, 9 minus 12 is 3 plus 1. Okay, minus, and then when you plug in 1 here, that's 1. Minus 4 is negative 3 plus 4 is also 1. And that gives you 2 on the bottom, and you get 0. Okay, so that's your first step. And when you do the second step, this is f prime of x. F prime of x is equal to 2x minus 4. And the third step is you'll just set these equal to each other. Okay, so there's your slope 0. And when you solve, you will get 2. Is 2 between the negative, the positive 1, the positive 3? Yes. Okay, and so this is your answer. Now you're looking at this and you're like, didn't you just do the mean value theorem? I did. Okay, now let me show you the trick and what Rolle's theorem is. Rolle's theorem is exactly the same as the mean value theorem. Okay, you still have this continuous, you have the differentiable piece, okay, which this parabola is. But here's the trick. Okay, for this work, and you have 3 steps, for Rolle's theorem, and if they tell you it's Rolle's theorem, the nice thing is you don't have to do step 1, okay? Because Rolle's theorem actually gives you a hint. And what it says is, it's the same thing as the mean value theorem. It's identical, but there's a promise involved. And the promise is that your slope will always be, for step 1, it'll always be 0. Okay, so it's kind of like Rolle's theorem is a subset of the mean value theorem. If you think about this as being mean value theorem and all the different problems that you have, Rolle's is just a small piece within it. Okay, and what it does is it tells you that your slope is 0. Okay, so if I say, hey, verify this with Rolle's theorem, you can take, step 1, all I'm going to do is scratch that out. You don't have to write any of that. You just have to say m is equal to 0. Okay, and then you just move on and do the second piece and then set this equal to 0 on the end. All right, so Rolle's theorem is actually easier than mean value theorem because you don't have to do step 1. You can just say, you know what? If it's a Rolle's theorem problem, I know it has to be 0. So, okay, I think that's all I have to share with you. This will be quick, I told you. And here's your assignment. Oh, sorry, I got one more. Sorry. Like bully. Okay, here's what you got. It says, as you drive by a Tempe police car, this will go by fast, your speed is clocked at 50 miles per hour. Okay, 3 minutes later and 5 miles further, you pass by another highway patrol officer who clocks you at 55 miles per hour. If the speed limit on the entire stretch of highway is 55 miles per hour, would the second officer be justified in writing you a speeding ticket? Okay, and so it's kind of weird. Like, here you are, you got the first police officer, it's Tempe, and you're going a good speed, 50 miles per hour, that's under the radar. And if you got the second guy who's over here, highway patrol, okay, got you going 55. Well, that's not speeding either, but here's what they say. It says you traveled 5 miles, okay, in 3 minutes. Okay, at any time here were you speeding? Okay, and so yeah, I'm sure there's times when you're going faster or slower, but what is your average speed? What is your average velocity? Okay, and so if you take a look, here's what you're doing. You're traveling a total of 5 miles. Okay, and you did it in 3 minutes. Now, that's not the same unit as what you have for the directions. You have 55 here, you got 55 here, you got 50 here. They're all in miles per hour, and that's not what this is. So let's think about this. 1 hour is how many minutes? Well, that's 60 minutes. Okay, so let's think about this. How many would 3 minutes be? Well, sorry. 3 minutes would be how much of an hour if I'm doing things in miles per hour? Well, if I go from 60 to 3, that means you divide it by 20, and I'll do the same thing here. 3 minutes is the same as 1/20th of an hour. Okay, so that's what I'm going to write. I'm going to say 5 miles per hour. 1/20th of an hour. Okay, and so while I started and finished at reasonable speeds, 5 divided by 1/20th is 100. Okay, which means your average speed, okay, between here and here, even though you finished at different marks, was 100 miles per hour. Okay, and so yes, your police officer has a right to give you a ticket, okay, because this is your average velocity, which means somewhere, between your A point and your B point, you definitely broke the speed. Okay. All right, that's all I have for you. I promise. Let me go to the next slide. There you go. There's your homework. You can see how I bet you these are. And this is just a guess. Some of these are mean value theorem. Some of them will be Rolle's theorem. But again, remember, Rolle's theorem is just like mean value theorem, except it's easier because your slope is always going to be 0. So if you have any questions, you let me know. You have a great day.